In this video, I'm going to explain how do we use SIMAC, which is a linear accelerator simulator, to learn about some LINAC physics. So I've come to the webpage where SIMAC lives. The webpage is linax.ca, linax.ca, and this is the webpage you come to. In order to use SIMAC, you have to log in. You can do that if you don't have an account. You can do that by clicking the sign up button over here. You click on sign up, and then you get an account. I already have an account, so I've chosen the username Marco, so I don't need to set that up. But if you can do that, you set it up. You have to agree to our terms and conditions of service, and then you can sign up for free. So I'm just going to go in and log in as myself. So I go to my login button. Here is my username and account password. Press login, and I get back to the home screen with my name over here showing that I'm logged in. There's a number of features that you can get to on the SIMAC webpage. There is the SIMAC application itself, which is here. We also have a LINAC primer, which is the second tab over here, and this is a short overview of how linear accelerator physics works. We have some pull-down menus, and it shows some different features of linear accelerators, particle acceleration. These are explains some of the basic things about waveguide physics. Right now, though, we're going to go back and we're going to use the SIMAC applicator, and we're going to explore what happens when we change some of the parameters on the linear accelerator. So right now, the application comes up as it has a 15 MV beam chosen, because that's what I had when I came in last time. And what it does is it shows the parameters that it's using in order to create that 15 MV beam. So the parameters for the RF driver, cholesterol pulse voltage, gun voltage, bending magnet current, and so on. And then it displays some of the properties of the beam. If you go to the analysis tab, you can see what the beam profile looks like. So this profile was made with a flattening filter, which needs a bit of improvement, and we'll see how to improve that in a later video demonstration. So coming back to the SIMAC applicator, first thing I can do, I can show you how to change the mode of the machine. So now I can turn this off by going to by clicking from 15 MV and selecting off. Now we have all the parameters that are set to 0, and we have no dose rate because we have the machines off. If I go back into 15 MV mode now, it now populates the simulator with some default parameters. So we have RF drive power over here, and if you hover over the number, it tells you what it is. We have over here, we have the cholesterol voltage, we have the gun voltage, and we have the bending current. So all the numbers that are in black are numbers that can be adjusted. If you click on them, then you get a pop-up and tells you what it is and what its value is. If you click outside, it goes away. There are also steering coils that we can change. So here is the radial bencher coil. This is simulating a varying linear accelerator. There's also the radial position coil, and then the transverse position coil, and as well as radial angle coils, which are over here. So what I'm going to do now is I'm going to adjust the RF driver power from 67 watts to 100 watts, and what we're going to do is we're going to look at how this affects the performance of the accelerator. So right now with these parameters, we have a beam energy exiting the accelerator of 14.73 MeV. The bending magnet is set to allow 15 MeV electrons to go through, which we see over here, and we have a target current of 7.23 milliamps. So if I change the RF driver from 67 watts, I'm going to go to 75 watts by clicking on the number. The pop-up comes up, and then using the arrow keys, I can increase that to 75. I hit enter, and now we've populated with 75. The RF power coming from the cholesterol drops a little bit. It goes down to 5.59 megawatts. And the beam energy coming from the accelerator also drops a little bit. However, we haven't changed the bending magnet, and so it wants to let the same energy electron through because the bending magnet is a type of spectrometer. So now the beam current striking the target is decreased. It was around 7 milliamps before. It's now 6.84, and so our dose rate has dropped a little bit. If we continue this, I'll go from 75 watts now up to, say, 85 watts. Now our dose rate is going to drop a little more because now again because the reason the RF drive power is dropping with an increased RF driver power, the output power of the klystron dropping is because the klystron is beyond saturation. And so now we have a lower RF power coming from the klystron, which means less ability to accelerate electrons. So the electron energy coming from the accelerator is now dropped to 14.43 MeV. If you recall, we started at around 14.75 MeV, which means a reduced current at the target and a reduced dose rate. And finally, if we go all the way now to 100 watts, so now we see now the power coming from the klystron has dropped quite a bit because we're quite a bit beyond saturation. So we're now down to 5 megawatts. Beam energy from the accelerator is 13.8 MeV. But again, the bending magnet wants to let only 15 MeV electrons go through, and there aren't many of these left because most of the mean energy of the electrons is down at 13.8. So just scraping off the very, very high energy electrons that are left over, there's only 0.68 milliamps of them, which leads to a dose rate of 32.4 centigrade per minute. So the short video explains a little bit about how we access the simulator and how we can adjust the RF driver and observe what happens with some of the parameters of the accelerator.